Okay, so in this lesson, we're going to start talking about our volume measurement unit. So this first lesson, we're going to talk about perimeter. So perimeter is the distance or length around a shape that surrounds a two-dimensional shape. All right, so we're going to be using a lot of like SOHCAHTOA, like Pythagorean theorem, all like the stuff we kind of learned to like. We're going to do perimeter on kind of like a higher level. All right, so let's take a look at exercise 1. So enclosure has the shape of a trapezoid with 3 known side lengths shown in feet. So let's first determine the length of side AD. Okay, so we want to find this. Now this is the height of a trapezoid. Now this side is the same as this side, so this side's 8. Now this side is 11, okay? Because this whole side is 17, this little part is 6. Now we're going to use this right triangle to help us find the length of AD. So we're going to use Pythagorean theorem. So this side is my C, my A, my B. So I'm going to do 6 squared plus 8 squared is equal to C squared. Okay. So 6 squared is 36, this is 64. So 36 plus 64 is 100. And then square root, so 10. So the length of AD is equal to 10. So now we want to find the perimeter. So perimeter is the distance around. So we're just going to add up all of the sides of the trapezoid. So we're going to do 10 plus 11 plus 8 plus 17. And that's going to give us 46 feet. Okay. So for part C, if the enclosure is to be surrounded on all sides by fencing that costs 75 cents per foot, then how much will it cost to enclose this entire trapezoid? So around the trapezoid is 46 feet. Now, per 1 foot, it costs 75 cents, okay? We're going to be doing a lot of unit conversions in this unit, so I kind of want you guys to get in a headspace of unit conversions, even though this is a pretty basic one. So we have feet on top, feet on bottom. So all we're doing is 46 times 75, so which is equal to 34.50. And that's how much it's going to cost. Okay. All right, so let's take a look at 2. So the biggest thing to know is that there's no like formulas specifically to find perimeter. Perimeter, I guess, is just more of like a concept, and like you guys just really need to know that it's the distance around a shape. Okay. So let's take a look at exercise 2. So parallelogram EFGH has vertices at E 1, 7. So E is 1, 7. F is 8, 7. G is 4, -3. And H is -3, -3. All right, so this is a parallelogram. Now we want to find the perimeter of this parallelogram to the nearest tenth. Now, the EF and GH, so we know that in a parallelogram, opposite sides are congruent. Okay, now EF and GH, as I was saying, is on a horizontal line, so it's easiest for us to count the units. So this is 1, 2, 3, 4, 5, 6, 7. So this side is 7. So this side is also 7. So EF is equal to 7, and the length of GH is equal to 7. Okay. So now we need to find the length of EH and FG. Now we can go ahead and we can do distance formula and all great. However, I just want to show you a little trick. In the coordinate plane, you guys could actually use Pythagorean theorem to find the length of a segment in the coordinate plane like this. Okay, and I'll show you how. So I drew in like a little right triangle where the length of EH is the hypotenuse. So this side is 1, 2, 3, 4. And this side is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so here's my right angle. So I'm going to do 10 squared plus 4 squared is equal to EF squared. So this is 100 plus 16 is equal to EF squared. So EF is equal to the square root of 116. Now I'm not going to simplify it yet, so we just want the nearest tenth. Okay. Now we know this is a parallelogram because this is a parallelogram. The length of FG is also 116. Okay. Now perimeter, we add them all up. So I'm going to do 7 plus the square root of 116 plus the square root of 116. I am not rounding just because I want an accurate answer. All right. So when I go ahead and add all of these up, I'm going to get 35.5406 5923, so which rounds to the nearest tenth, 35.5 units. You guys have to be very diligent and be very careful about what they want you to round to in this unit, okay? All right, so let's take a look at the next page. So exercise 3, so a wooden frame is to be made using wood that costs $1.25 per linear foot. The frame is in the shape of a right triangle whose hypotenuse is 12 feet and which contains a acute angle of 32 degrees. Determine the overall cost of making this frame. So first, we need to find perimeter. Now, we are given a right triangle, we are given an acute angle, and we were given the side of one of the sides of the triangle. So we are going to use SOHCAHTOA for this. Okay. Now, I'm just going to label this just so when I do this, it kind of makes sense to me to keep all my links in check. So we need to find the length of AB and we need to find the length of BC. So let's start with AB first. So here's my angle. This is my opposite and this is my hypotenuse. So to find X, we're going to use sine. Okay, so we're going to do sine of 32 is equal to X over 12. So now this is over 1, so I cross multiply, so 12 times the sine of 32 is equal to X. Now hold on, now you guys are going to run to your calculators and find the decimal. Yes, okay, but I want you to get into the habit of not rounding too early. So I'm going to hold on to this and we're going to put it all on our calculator at once so we don't screw up our answer in the long run. Okay, so let's find y now. So y is adjacent. So to find y, I'm going to use cosine. So cosine of 32 is equal to y over 12. So again, cross multiply. So I get 12 times the cosine of 32 is equal to y. Now I have y. Now I have x. Now I need to find the perimeter. So the perimeter is all of this distance. So it's x plus y plus 12. So to find the perimeter, I'm doing 12 times the sine of 32 plus 12 times the cosine of 32 plus 12. So let's put all of that in our calculators. So we're doing 12 times the sine of 32 plus the cosine of, 12 times the sine of 32 plus 12 times the cosine of 32 plus 12. So my perimeter is equal to 28.53560,832. Okay, but that's not our answer though. We want to figure out the actual cost of making this frame. So would cost $1.25 per linear foot. Okay. So per 1 foot, it costs $1.25. So my feet cancel. So 125 times this is equal to $35.23. And that is my final answer. Okay. All right, so the last little bit of this lesson, we are going to talk about how to find the perimeter of a polygon. Now, this is a little wild, so bear with me. Now, first of all, a vocab word, a regular polygon is a polygon with all congruent sides. So all of the sides are congruent, all of the sides are the same, all of the angles are the same. Okay. So let's look at 4. So a regular pentagon is drawn such that the distance from its center point to any one of its vertices is 5 inches as shown. So the radius is 5. So all of these lengths in a regular pentagon, so like a circle, a circle and a radius is the same all the way around. So quote unquote, the radius of a regular pentagon is the same from the center point as with like a circle. Okay. Okay, so let's continue reading. Okay, so point B is at the midpoint of side AD and CB has drawn. Okay, so B is the midpoint of AD, so this is congruent to that. Okay? So now what is the measure of angle ACB in this diagram? Now, they gave you a little hint, don't use trig. We're not going to use trig for this. Okay? Now, this is what we call a central angle because the vertex is at the center. All right, now to find a central angle of a polygon, we're going to do 360 divided by the number of sides. Now this is a pentagon, so a pentagon has 5 sides, so we're going to do 360 divided by 5, which is 72. Now this angle is not 72. This angle, it is what, 72. But this right here, if you want to think about it like this whole triangle, ACD is an isosceles triangle because this is equal to this. So, and we know that the height of an isosceles triangle bisects the vertex angle, cuts the base in half, and is the altitude, so that it's perpendicular to the other side. So if this whole thing is 72, then each of these little pieces is 36. Okay? So the measure of angle ACB is equal to 36. Okay? Now we want to determine, for the second part, we want to determine the length of side AB. So this one is where we actually are going to use trig. So I'm going to take apart this triangle so it's easier for us to see what's kind of going on here. So this angle is 36, this side is 5. Now for us to find the length of AB, we are going to use SOHCAHTOA. We're going to use sine, because this is my opposite, this is my hypotenuse. So we're going to do the sine of 36 is equal to x over 5. Okay, so now to solve for x, we're going to cross multiply. Now, stop right here. It says leave your answer unrounded, and here's why. For part C, it's asking us to find the perimeter of this pentagon. Now here's the thing. So each one of these little triangles with the dotted lines, all of these triangles are isosceles triangles, okay? So all of these have this height that can be drawn. Now all of these pieces are all equal to the same thing. So they're all equal to the value of x. So to find the perimeter of all of this, we're going to take this length and we're going to multiply, or we're going to add this up however many times. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 x's. Okay, so 10 segments equal to the length of AB. So what we're gonna do to find the perimeter is we're gonna take 10, we're gonna multiply it by the length of AB, which is this, okay? So let's go to our calculators now. So 10 times the 5 sine of 36 is equal to that. So the perimeter of the pentagon is equal to 29.3892661. So the nearest tenth, our answer is going to be 29.4 inches.